Okay, so let's say I ask you to simulate your design. Simulation is pretty important. It's not the same as putting it on a board, but simulation will help you save time, basically, verifying whether or not the code or the design you implemented is actually correct. So let's say we start with our project file here, and let's see here. Let's go to Files, and we have a test.v file. I wrote a pretty simple module here, just doing an I equals A or B or C, doing an assign J equals A or B or C, and we have also K equals AX or B. Pretty simple. This is basically combinational logic here that we're testing. So we have a test file here. This is the file we want to test. So if this is the file we want to test within our project, what I'm going to do is make sure, usually it comes up in hierarchy. We're going to change it to Files, and I'm going to right click on the test.v file because that's the one I want, and I'm going to click Set as Top Level Entity. Okay, so we've set the top level entity, and let's say we want to test this file. We want to make sure that every single time we change something in the file, we run the analysis and synthesis step again. Okay, so now we're going to go ahead and make a university vector waveform file. This is pretty much the easiest way to simulate. I'm going to go click here for New, and I'm going to go to University Program Vector Waveform File, and click OK. Alright, so we got the simulation waveform editor here. I'm going to right click in this area, go Insert Node or Bus. I'm going to do Node Finder. I'm going to list it, and in this case I want them all, so I'll just do this move over to selected nodes and click OK. Actually, I don't want D because I'm not using D. So I'm going to click OK. And then I'm going to click OK again. And it should show up in this area right here. Your A, B, C are inputs, and I, J, K are, it's basically hatch because that's basically the output value. So in the simulation, we have three input values, A, B, and C. A, B, and C are basically binary values. It's a 0 or a 1, so there's two possible values. So there's 2 to the 3 possible combinations. So what I'm going to do is, first of all, set the grid end time to be 1 microsecond. And I'm going to also set the grid size to 100 nanoseconds. Okay, so we have 8 possible values. We have the possibility that A, B, and C will all be 0. So 0, 0, 0, 0, 0, 1, 0, 1, 0. So we're just going to count off, okay? So 0, 0, 0, 0, 0, 1. Just drag and click 1. 0, 1, 0, 0, 1, 1. And I can actually drag both of them. 0, oh actually it's 1, 0, 0. 1, 0, 1. Oops. And if you make a mistake, you can just go here and just set it back, right? Just drag and click the 0. So we're up to 1, 0, 1. Then we're going to do a 1, 1, 0 and a 1, 1, 1. So 2 to the 3 possible values, we've counted 0, 1, 2, 3, 4, 5, 6, 7. So that's 8 different combinations. So we basically set up the inputs for A, B, C, and it's hatched for I, J, K because we don't know what they are. I'm going to do a Control S, and I'm going to save it as let's call it wave.bwf. Okay, so we've saved it. Then we're going to run the simulation by doing simulation and run functional simulation. When we press this, it's going to actually launch Model Sim as the back end. If you get an error during this step, make sure that you actually make sure that your analysis and synthesis is actually completed successfully. Okay, so when it comes out, you'll see another simulation waveform editor window open, but it'll only be read-only. So this read-only window actually has the IJK combinations, or the IJK output values. So let's see here. The first value I was configured as I equals A and B and C. So I equals A and B and C is only true when A, B, and C are true. So 1, 1, 1 is equal to a 1. That seems to be correct. Otherwise, it's all 0. So what was J? I think J was A or B or C. So if any one of them is 1, then J is true. So C is 1, so J is true here. B is 1 here and here, so it's 1. J is 1 here. A is 1 here, so J is 1, and so on and so forth. The last one is A. K equals A, X, or B. So K is equal to A, X, or B. Since they're both 0 here, they're 0 here. And B is 1 here and A is 0 here, so 1 XOR 0 is equal to 1. And over here, 1 XOR 0 is 1, and 1 XOR 1 is equal to 0. So it seems like our simulation waveforms, our output waveforms, are indeed correct. So to recap, whenever that, you only have to generate that waveform, a vector waveform file once. So we went here and we basically clicked on University Program Vector Waveform File. Now, after that, after you've saved it, it'll come up in your project navigator here. In this case, I called it wave.vectorwaveformfile. Double click here, and your inputs will come back. Okay, and all you have to do is click Simulate and run functional simulation. Another thing to note is you need to have your analysis and synthesis complete. You need to have a check mark over here anytime you change the code here.